All right, we're recording that day, actually Fridays, day late. Where is it? No, that's not it. Here we go. Okay, and here we go. All right, so unit 4 was ratio and rates, hopefully. So you need to fill in this, I'd rather you fill in this page after you do the exercise. Okay, I think that makes sense. So we'll start with the first question. Here you have a trail mix. You have 5 cups of pretzels, 3 cups of peanuts, 2 cups of raisins, and one cup of chocolate chips. Right, each ratio in 3 different rates. Pretzels to peanuts. So pretzels we have 5, so we can write 5 to 3 colon 5 to 3, which is actually on the word 2, and 5/3. Okay. Total trail mix to raisins. So the total would be, we add all this up, 5, 8, 9, 10, 11. So we have a total. Raisins, we have to 2, so it's 11 to 2, 11 colon 2, 11/2. Okay. Let's just go down a little bit more. Peanuts again to chocolate would be 3 to 1. Okay, 3 to 1, 3 to 1, 3/1. Okay. Wait, let me see if I can make this page a little smaller. Not too small. All right, so, and then 2, the ratio of tables to chairs is 1 to 6. Are there more tables or are there more chairs? Well, it says there are 1 table to 6 chairs. So we're comparing the number of chairs, number of tables to chairs. The one, okay, so the order, it's in order. So the table refer to number 1 and the chairs refer to number 6, and that's how I know that there are more tables to 6 chairs. So anytime you write a ratio, order does matter, okay? So because I said table first, the 1 refers to the tables and the chairs refers to the 6, okay? So just a quick rundown, memory lane here, the basic on how to write ratios. 3, write 3 ratios equivalent to the ratio given. So write 3, I think they're asking you, so to write, so here's 12/28. I'll write it like this because I think it's easier. Write 3 new ratios that have the same meaning as 12/28. So you can either simplify, you can scale up, you can scale down, or you can write 6/14. That's the same. And then I can actually write 3/7. That's also the same. If I wanted to go higher, let me double 12 to 24. And let me double 28 to 56. So there is actually 3 different. 1, 2, 3. 5/2. Let me write 5/2 as a fraction. So here you go, 5/2. I don't like to deal with decimals, so I'm not going to scale down. You could write 2.5/1, but that's, that's okay too. Or you want to go higher, you can write 10 to 4. Or let me go even higher. I can multiply 5 by 100. I go 500. I'll multiply 2 by 100 as well, and I get 200. So there we go. 3 different ratios that have the same meaning as 5/2. 10/3. Let's go higher. 100 over 100 times 10, or 100 over 30. Let's multiply by 2, double it. 20/6. Let's times, I don't know, by 5. So 10 times 5 is 50. 3 times 5 is 15. Okay, so again, it's immense number of possibilities, whatever your choice, as long as however you increase the top, you must increase the bottom by whatever factor, whatever you multiply the top by, or even divide it by. Just make sure you do the same top and bottom. Okay. Right, each pair of equivalent ratios. Okay, so we had a ratio 5 to 6. Okay, so let's see. How did 6 become a 24 times 4? So here would be times 4 as well, which gives you 20. How did the 1 become an 8 times 8? So times 8, 32. All right, so again, you'll notice that I multiply top and bottom by the same factor. Okay. Here, we're actually scaling down. How does 6 become a 3? Divide by 2. And I'm going to divide this by 2 as well. Okay, it gives me 15/3. Write an equality to compare. So 5/10, 8/10. So let me just write it 5/10 like this and 8/10. Okay, so inequality, is it greater? Is it less? You can grade, or it's even equal. Okay, so 5/10 obviously is less than 8/10. Now we have 2/3 and 3/4. Okay, now can't compare these two because the denominators are the same. The pieces are different. The denominators are different. So one choice he makes to make the denominators the same. So let's change this both to 12. Okay, so the 2/3 to become, so how did the 3 become a 12 times 4? So top times 4. So now we have 8 over 12. And 3/4, to change something over 12, it's times 3 on top. So it's 8 over 12 and 9 over 12. Now it's much easier to compare. And 8 over 12 is less than 9/12. Okay, so this is less, and this is less. In the box below, use a table to find the equivalent ratio. So, now notice that here, you don't have a relationship. Nothing multiplied give you times 6 will give you 8. Up and down also doesn't work. So we want to change the 6 over 9 to something else. Okay, so let's change something that will help us with the 8. Let's see if we can go. Let's change the 6 and make the 6 into 24. How did I do that? Multiply by 4. And I'm going to multiply the 9 by 4 too. And I'm going to use this. Okay. The reason I have 24 is because the 24 now has a relationship to 8. Okay, so 24 was a good number. So I'm not going to use this anymore. And I'm going to use 24 over 36 to now find my denominator here. What's the relationship between 24 and 8? 24 to become an 8 is divide by 3. So 36 divided by 3 will give you 12. Okay, so remember this. This was one where we had to change this particular ratio to a new one in order to find a relationship. Okay. All right. So next one. What's the unit price? Price quantity. Okay. I bought 6 apples, and the I bought 6 apples, and the price per apple. So let's write it as a, first of all, write it as a fraction. So you bought $1.50. Remember, money usually goes up on the top, $1.50, and I get 6 apples. And I'm going to divide that, and $1.50 divided by 6. Hang on a second. I divide top and bottom by 6, right? Remember how to change to unit rate? So we're going to change this to find the unit rate. We want to find the price for 1 apple. So this is apples. So the 6 to become 1 is divided by 6. And 150 divided by 6 is what you want as well. And 150 divided by 6, let's see. Is 25 cents. So the price for each apple is 25 cents. Apple B, kind B, I'm sorry. You paid $3.15 for 15 apples. Okay, so you want to change this to 1 apple, right? Because that's what unit rate is. You're comparing it to 1 item. It's divided by 15, so I'm dividing top and bottom by 15. Okay, $3.15 divided by 15, you're going to divide this by 15, and you're going to divide this by 15. It gets you 21 cents. Group C here, you paid $5.80 for 20 apples. So again, change the denominator to 1 apple. How do you do that? You divide by 20. And divide the top by 20. 580 divided by 20. I believe it's 26 cents. 29 cents, sorry. Which is the best buy? Apple B, or kind B. Okay, it's the best buy because it's cheaper for each apple. Okay, it's 21 cents for 1 apple. Okay, so this is how you do unit rate. Okay, change everything here so that you can find the price per 1 apple, and then you can compare. 2, find the unit rate for each. Okay, so find the unit rate. Let's write it as a fraction first. I think it's easier if you look at it that way. 0.98. And you're going to do over 2 lemons. So the unit rate would be, what's the price for 1 lemon? So how did the 2 become a 1? You divide it by 2. So 2 divided by 2 is 1. And you're going to divide 98 cents by 2. And that's simply 49 cents. So the unit rate is 49 cents per lemon. Here you paid $3.60 for 45 labels, and you want to find out what's the price for one label. And you're going to divide top and bottom by 45. Divide this by 45, gives you 1, and you divide 360 by 45. And that's going to give you 0.08 cents. Okay. Last one, 360 miles in 6 hours. Miles in hours. You want to know how much you go in 1 hour. Divide by 6. Divide by 6. And that's going to be 60 miles in 1 hour. Okay, and that's your last question. Okay, let's see. Reese's birthday party will cost $15 if he invites 3 friends. What should the cost be for 5 friends? Well, let's figure it out. So here, set it up. $15, 3 friends, right? All right, friends. Set it up as a proportion. On the other side, write 5 friends. How much would it cost? Well, is the relationship between 3 and 5, is the relationship going this way? Is anything you know multiplied by 3 gives you 5? No. So, side to side, remember I asked you to always look side to side, but you also can look up and down, right? How does a 3 become as 15? Times 5. So, here, I can also multiply times 5, which is going to give me 25. So, for 5 friends, you end up paying $25. So look side to side first. If not, look up and down. Okay. Okay. Did Sue and Jim drive at the same rate? Well, I can't compare. So one person drove 48 kilometers in 24 minutes. The other person drove 56 kilometers in 28 minutes. Remember when you did the eyelids? The blinking of the eyes and jumping jacks, and 2 people were doing 2 different things, same thing, but different speeds. Here is the same thing. Can we compare these 2? No, we can't. So let's see if you can find something that is in common here. Okay, so best way to do this is to find the unit rate. So I would divide this by 24. So to find out how much this person is Sue, she does in 1 minute. So 48 kilometers in 24 minutes, or in 1 minute, she drove how much? Well, 24 divided by 24 is 1, and on top is 48 divided by 24, which is 2 kilometers. So, in 1 minute, Sue drove 2 kilometers. Let's talk about Jim. Again, we're going to change this to a unit rate. 28 minutes to become 1 minute, divide by 28. So I'm going to divide the top by 28 as well. And that's going to be 2 kilometers. So, did they both drive at the same rate? Yes, they were driving at the same speed, okay, because their unit rates are the same. Complete the table. Oh, yay. Okay, so this one, very clearly, I think it be the easiest. An up and down relationship, this is easy. So, to go up, it's divide by 50, and to go down would be times 50. So depending on where you are. Let's start here from the corner. 5, we want to go down because the down is the mismo, so it'd be times 50. It's going to give us 250. The 200, we need to go up. It's divide by 50. It's going to give us 4. 3, it's going to be times 50 because we're going to go down, and it's 150. And 125, it's going to go up, so it's going to be divide by 50. Okay. That's going to give us 2.5. Okay, so again, if there was a side to side that you can use a side to side, but this one was easier if you worked it up and down. 2, what is the ratio of distance to time? The ratio of distance to time, you can pick any of these ratios. This one, this one, this one, and this one, or this one. So the ratio, let's pick this one right here. Distance is 200, and the time is 4. The distance is 200 miles. To 4 hours. If you pick that one, let's pick the last one. It's 250 miles to 5 hours. So you could have picked any of these, and you would have meant the same. Okay, so they're just different representations. Okay, how far did the bus travel in 1 hour? Well, to go 1 hour, this says 2 hours. So let's just create another box for 1 hour. So 1 hour to go down is 50, right? Times 50. So in 1 hour, he goes 50 miles, okay? Just because there is no box for 1 doesn't mean you can't extend that table and find the value for 1. Okay. Write the information in the table as ordered pairs, uses hours as okay, so I erased everything. So, okay, so I can. So let me just erase a few things. So I'm going to write the information as ordered pairs. So where am I? And here we go. So I'm going to write the order, and I think I know what they want. So order pair, hours of the hour. So let's start with this one. So you get 2, comma 100. So that's the first one. Second one is 2.5, comma 125. Third one is 3, 150. Fourth one is 4 and 200. And the fifth one is 5 and 250. Okay, so I assume that they want us to use these ordered pairs to graph. Okay, and that's okay. And the graph is already labeled for us. So 2 and 100, so 2 hours would be right here, 2 and 100. 2.5 and 150 would be right here. 2.5 and 125, I'm sorry, right here. 3 and 150. How's this going? 1, 2, 3. Their numbers here are weird. I don't like how they wrote the numbers. 350. 4 is this one. I don't know why. They did a horrible job, by the way, in labeling their numbers here at the bottom. See how on the y-axis, the 500 is right here on this line, at this line, and meanwhile the numbers at the bottom here is in the middle of the box. It shouldn't be that way. 5 and 250. And here's your straight line. Okay. What's the unit rate distance traveled in 1 hour? We already answered that. In 1 hour, we can look right here. In 1 hour, it's right here. That's 50 miles. Can we use a graph to find out how much you will drive in 7 hours? Yes, right here. And 7, okay, 7 hours over here. And you go all the way up here. And 7 should be 450. No, 5, 6 is going to be 300. 7 should be 350. Wow, this is one ugly graph. Wait, 5 is 250, 6 is 300, 7 is 350. Okay, so there's something weird with this graph. 1, 2, 3, 4, 5, 6, and 7 should be this one. Okay, so these numbers here at the bottom are all wrong. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, and that's 7. Yikes. All right. And then how can you use the unit rate to find the distance traveled in 8 hours? How far will the bus travel? So the unit rate is this. 50 miles, right, in 1 hour. Here's the unit rate. So in 8 hours, you can set up a proportion. Times 8, and that's going to give you 400 miles. And that's how I would use the unit rate to find how much was driven in 8 hours. Okay. And that's that. Wow, that was short. So that was unit 4.